This is the OCR GCSE 91 Maths paper 4 from the November 2021 series, and this paper is a calculator paper. Question 1. We have to calculate for part A 6 squared plus 5 all cubed. First of all, if we open up our bracket and then type in 6 squared plus 5 and then close the bracket, and if we then cube this result, it turns out we get 68,921. Next, for part B, we have to write the answer to the square root of 8.4 squared subtract 1.9 squared divided by 2.5 plus 5.7 correct to 3 significant figures. Well, if we input this into our calculator, we press the square root button, we then press the fraction button. For our numerator, we have 8.4 squared subtract 1.9 squared. For the denominator, we have 2.5 plus 5.7, and if we write down the result of this calculation, we end up with 2.857 394. And now we need to write this to 3 significant figures. And if we were to write this to 3 significant figures, if we take a look at the first 3 figures, the figure after it, which is 7, is greater than 5. So we need to move this 5 up to the next digit, and therefore what we end up with is 2.86 to 3 significant figures. Question number 2, we have to calculate the area of this trapezium. We have our 2 parallel sides, 8.7 centimeters and 12.3 centimeters. We have the height, 6.8 centimeters. If we now work out the area, well, for the area, we would have 1/2 multiplied by the sum of the 2 parallel sides. We have 8.7 plus 12.3, and then we multiply this by the height, 6.8. And so if we work out the area, well, if we type this into our calculator, we have 1/2 multiplied by 8.7 plus 12.3 in brackets multiplied by 6.8. It turns out we have 71.4, and the units will be centimeters squared. So we have 71.4 centimeters squared. Question number 3, we have to simplify x raised to 12 divided by x raised to 4. Well, if we were to rewrite this calculation, we can rewrite this calculation as a fraction. We have x to the 12 divided by x to the 4, and if we work this out, then what we need to do is subtract the indices So we have x to the 12 subtract 4, which is the same as x to the 8. So we have x to the 8. Question number 4. Lee throws 2 fair 4-sided dice, each numbered 1, 2, 3 and 4. Lee multiplies together the two numbers that the dice land on to produce a score. We have to find the probability that Lee's score is a prime number. Well, if we create a sample space diagram, such as the one we see here, we've got the first die, we've got outcomes of 1, 2, 3 and 4, and the second die, we've got outcomes of 1, 2, 3 and 4. If we multiply the two scores together, 1 times by 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 2 times 1 is 2, 3 times 1 is 3, 4 times 1 is 4, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 3 times by 2 is 6, 3 times by 3 is 9, 3 times by 4 is 12, 4 times by 2 is 8, 4 times by 3 is 12, 4 times by 4 is 16. Now, we have to find the probability that Lee's score is a prime number. Well, what are the prime numbers here? 2 is a prime number, 3 is a prime number. Our only prime numbers are 2 and 3. 1 is not a prime number because it only has a factor of 1. So therefore, the probability that Lee's score is a prime number, well, out of 16 outcomes, 4 of those are prime numbers. So we have 4 prime numbers out of a total of 16. And this fraction can be simplified to 1/4. So therefore the probability is 1/4. Question number 5. For part A, fountain A squirts water every 24 minutes. Fountain B squirts water every 42 minutes. They squirt water together at 15:19. We have to find the next time they squirt water together. So we've got fountain A and fountain B. Well, what's happening is A squirts every 24 minutes, B squirts every 42 minutes. So if I take a look at A, we can add on 24. And if I take a look at B, we can add on 42. And what we need to do is find out the common time when they squirt together next. So, if I add on 24 minutes to 15:19, well, I've got 19 minutes plus another 24 minutes. That takes me to 15:43. And now I need to add on another 24 minutes. Well, if I add on another 17 minutes, that takes me to 4 o'clock. And then I've got another 7 to add. So that takes me to 16:07. Again, add on 24 minutes to this, so I'm at 4:07. And if I add on 24 minutes, I get 16:31. And then if I add on another 24 minutes, I get 16:55. And then if I add on 24 minutes, well, if I add on 5 minutes, that takes me to 5 o'clock. And then if I add on another 19 minutes, then we end up with 17:19. And then adding on another 24 minutes, well, we'll end up with 17:43. And then on another 24 minutes, we end up with 18:07. Another 24 minutes, 18:31. And another 24 minutes, we end up with 18:55. We'll stop it there for now. And then if I add on 42 minutes to fountain B, well, we've got 19 minutes, and if I add on 42 minutes, that takes me to 16:01. And if I add on 42 minutes, that takes me to 16:43. And then if I add on another 24, rather another 42, then we end up with 17:25. And if I add on another 42 minutes, we end up with 18:07. So the next time this squirt water together, you can see then that is 18:07. So we have 18:07. For part B of the question, a school sends 60 students from Year 8 and 105 students from Year 9 to a museum. The school divides these students into groups using the following rules. The groups must all be the same size. All students in any group must be from the same year. There should be as few groups as possible. We have to find the size of each group and the total number of groups. Well, we've got 60 students in Year 8 and 105 students in Year 9. What we need to do is split these such that we've got the groups having the same size. And so if we want the groups to have the same size, what we need to do is find the highest common factor. So for us to find the highest common factor of 60 and 105, well, if we write 60 as the product of its prime factors using our calculator, we see that 60 is equal to 2 times 2 times 3 times 5. And if we write 105 as the product of its prime factors, that's equal to 3 times by 5 times by 7. So when we come to find the highest common factor of 60 and 105, well, what you can see is common to both. We've got a 3, which is common to both. We've also got a 5, which is common to both. And so if we work out 3 multiplied by 5, what we would get is a value of 15. So what does this mean? Well, it means the size of each group is 15. So now what we need to do is determine how many 15s go into 60 and how many 15s go into 105. So if we work out 60 divided by the 15, we get a value of 4. And if we work out 105 divided by 15, we get a value of 7. And therefore, if we split the 60 up into 4 groups and the 105 up into 7 groups, so we've got 15 in each group, and we've got 1, 2, 3, 4 groups for year 8, and 1, 2, 3, 4, 5, 6, 7 groups for year 9. So therefore, for the total number of groups, we would have 4 plus 7, which is equal to 11. We've got 11 groups in total. The size of each group is 15. Question number 6. A shop sells the same milk in 3 different sized cartons. The diagram shows the price of each carton. We've got this first carton, the smallest one, 300 millilitres for 31 pence. The next one, 500 millilitres for 47 pence. And then the largest one, 2 litres for £1.96. For part A, which carton has the best value for money? Show how you decide. Well, if I take a look at this small carton, well, I've got 300 millilitres, which is equal to 31 pence. We'll write that in pounds. That's equal to 0.31 pounds. And so what we can do now is find out how much 100 millilitres is worth, and we can do that by dividing through by 3. And if I divide through by 3, 31 divided by 3, well, 0.31 divided by 3, that's equal to 0.103 recurring. If I take a look at the medium, we've got 500 millilitres costing 47p or 0.47 pounds. So 100 millilitres, if I divide through by 5, we get 0.094. So we've got 0.094. And if I take a look at the large, well, I've got 2 litres. Well, 2 litres is the same as 2,000 milliliters, and I want to find out how much this is. Well, that's equal to £1.96. I want to find out what 100 milliliters is worth, and I can do that by dividing through by 20. 196 divided by 20 is 0.098. So we've got 0.098. So which has the smallest value? Well, this has the smallest value, which means the medium is the one which has the best value for money. So therefore, we have the 500 milliliters, which has the best value for money. So, part B, a student only buys milk on a Saturday morning. They use 120 milliliters of milk each day. Any unused milk has to be thrown away at the end of the following Friday. We have to show that it is cheaper to buy the milk they need in 300 milliliter cartons than in 500 milliliter cartons. Well, first of all, Saturday morning to the end of Friday, that's 7 days. So what we can do is find out the total amount of milk we require. So if we do 7 multiplied by 120, it turns out we have 840 milliliters milk required. So if we have 840 milliliters required, and we have 300 milliliters for the small cartons, if I do 840 divided by 300, we get 2.8. So we require 3 cartons of the small. So what would be the cost of this? The cost of this will equal 3 multiplied by 31 pence, which is equal to 93 pence. And if I work out the 840 divided by the 500, what we get in total is 1.68, which means we require 2 cartons of medium, and the cost of this will equal 2 times by 47p, which is equal to 94p. So which is cheaper? The 300 milliliters would be cheaper. Question number 7. For part A, over a long period of time, it is found that the probability of a train from Beaufort to London being late is 0.2. For the first part of part A, one morning there are 2 trains from Beaufort to London. use the information to complete the tree diagram. Well, the probability that the train is late is 0.2, so we can fill this in the appropriate places. And therefore the probability that the train is not late is 1 subtract 0.2, which is 0.8. So we can fill in the 0.8 in the appropriate places. And therefore what we see here is the completed tree diagram. Next, we have to work out the probability that both trains are not late. The probability that both trains are not late, well, we have 0.8, that's the probability that the first train's late, multiplied by 0.8, that's the probability that the second train is not late. And if we work out what this is, it turns out we get 0.64. So we have 0.64. Next, give a reason why the probabilities used in the tree diagram for the second train may not be reliable. Well, unexpected events such as weather or strikes may occur, which may change the probability. Next, for part B, Morgan takes a train from London to Beaufort and then another train to Argonne. The tree diagram shows the probabilities of Morgan's trains being late or not late, and that's what we see here. Morgan will not catch the train to Argonne if the train to Beaufort is late and the train to Argonne is not late. We have to work out the probability that Morgan will catch the train to Argonne. First of all, we can find the probability that she will not catch a train. Well, she will not catch a train if the train to Beaufort is late, and she will not catch a train if the train to Argonne is not late. So therefore, the probability that she does not catch a train, that will equal 0.35 multiplied by 0.76. So if we work out this probability, it turns out we get 0.266. So the probability that they catch a train will equal 1 subtract 0.266, and if we work this out, we get 0.734. So our probability then is 0.734. Question number 8. Jamie invests £6,000 at a simple interest rate of R% each year. After 6 years, the value of their investment is £7,170. We have to find the value of R. So, the total amount of interest is equal to £7,170 subtract £6,000. The total amount of interest then, if we work this out, we get £1,170. Now, what we are doing then is investing simple interest R% each year, and after 6 years we get 1,170. So this £1,170 is the interest over 6 years. And therefore, if we work out 1170 divided by 6, we would get 195. So this 195 is the interest in 1 year. So if we invest R% each year of the 6,000 and then we end up with 195, that would mean then we have R% of 6,000 equaling 195. So R% is the same as R over 100. We multiply this by 6,000, we get 195. Now 6,000 divided by 100, that's just 60. So if I do 6,000 divided by 100, that's 60. So we have 60R equals 195. If we find out what R is in this case, we get 3.25. So we have 3.25 for R. Question number 9. The price of a plane ticket is increased by 15% to £1,426. We have to find the original price of the plane ticket. Well, if we let the original price equal X, then what we have is 1.15x equaling 1,426. We've increased the original price by 15% and we get a final value of 1,426. So if I do 1,426 divided by 1.15, we get 1,240. So X is equal to 1,240. That's the original price. Question number 10. Alex, Blake and Charlie play a computer game. Alex goes first and scores n points. Blake scores 8 points less than 3 times the number of points scored by Alex. Charlie scores 25 more points than Blake. The 3 people score a total of 618 points. We have to work out how many points they each score. You must show your working. So Alex, we know Alex, he scores n. Then if we take a look at how many Blake scores, he scores 8 less than 3 times the number of points scored by Alex. So we have 3n subtract 8. And then Charlie scores 25 more points than Blake. So if we take a look at how many points Charlie scores, we have 3n subtract 8, which is Blake's score, and then to this we add 25. So we know that in total the score 618. So we have n plus 3n minus 8 plus 3n minus 8 plus 25, and in total we get 618. n plus 3n, we know that's 7n. minus 8 minus 8, that's minus 16, plus 25, that's plus 9. And this is all equal to 618. So, if we subtract 9 from both sides, we have 7n equals 618 subtract 9, which is 609, which means if we solve for n is equal to 87. So we know that n is equal to 87. So now what we can do is find out the scores for Alex, Blake and Charlie. So therefore, Alex, well, we know Alex scores 87. Then Blake, he would score 3 times by 87, subtract 8. So if we work out what this is, we have 253. And then Charlie would score 25 more than this. So we have 253 plus 25, which is 278. So we have 87 for Alex, 253 for Blake, and 278 for Charlie. Question number 11. The diagram shows triangle ABC and ADE. B lies on AD and C lies on AE. BC is parallel to DE, and that's shown by these arrows here. We have to complete these statements to show that triangles ABC and ADE are similar. Well, the angle ABC, that is this angle over here, is equal to the angle ADE, which is this angle here. And that's because they are corresponding angles. Now, if we take a look at the angle ACB, ACB is this angle here, and what this matches up with is this angle over here of ADE, and that's because they are corresponding angles. And now the angle BAC, which is this angle here, well, do you notice how this angle is common to both triangles? So the angle BAC is common to both triangles, and therefore the triangles ABC and ADE, they are similar because of the angle property. Question number 12. For part A, the region R is shown on this grid. That's what we see here. And region R is defined by 4 inequalities. One of the inequalities is x is greater or equal to 0. We have to use the symbols less than or equal to 0 or greater or equal to 0 to complete the other 3 inequalities, as we see here. So first of all, we'll label the lines. Now, x being greater or equal to 0, well, that's just the y-axis. So if we were to label that, the y-axis is the line x equals 0. Then we've got y, and then we've got this half x. Well, that's going to pass through the origin with the gradient 1/2. And if I take a look at what's going on here, we go 2 across, 1 up, gradient's a half. It passes through the origin, which means that this line here is y equals 1/2 x. Then I've got x plus 2y with a 24. Well, if I think about it, when x is equal to 0, so when x is 0, we can cross that out, y is going to equal 12. And that's that point over here. But then when x is 14, say, so if I had 14 for x this time, so I'm going to write 14 over here, I've got 14 plus 2y equals 24, which means y is equal to, well, 2y will equal 10, y will equal 5. Let's confirm that. That point is also fine. So, the equation of the line here is y equals 1, rather we have the line x plus 2y equals 24. And then we've got y equals x plus 6, which is the remaining line here. So we have y equals x plus 6. Now we need to define these regions. Now, if we take a look at what's going on here, you can see we are above the line. So for this one, we would have y is greater or equal than 1/2 x. Now if I take a look at this line here, what you can see is we are below the line. So we have less than or equals to. Then we've got the x being greater than 0, so we've got x being greater or equal to 0. And if we take a look at the final line, we have something below the line. So we have less than or equal to. Then for part B, the inequality x is greater or equal to 0 is replaced by a new inequality, and the region is then a kite right down the new inequality. So if the region is a kite, well, we can form a kite like so. We've got a line here, and then we've got another line here. So we've got a line here, then we've got another line here. And if I have this bit but in the opposite direction, like so, such that now we've got a kite so we've got 1, 2, 3, 4 across and then 4 up. So if I go 4 across and then 4 down, then right now what we've got is a kite. So if I draw a line such as the line over here, remembering we've got a kite over here, so this line here is the line x plus y is equal to 6. We've got a kite now, and now our new region will go above the line like so to give us a kite for our region. So we've got region R now being a kite, which is what we see here. And our new inequality then will be x plus y. We've got a 6 on the other side, and we want greater than or equal to 6 because we're above the line. Question number 13. The height, h centimeters, of each member of a tennis club is recorded. The histogram shows some of the results. 40% of the members have a height in the interval 160 to 170. 30% of the members have a height in the interval 170 to 180. And 100% of the members have a height in the interval 140 to 200. What we have to do is complete the histogram for the intervals 170 to 180 and 180 to 200. Well, what we will do so far is find out the frequencies of the bars we already know. Now here, we've got 20 multiplied by 0.7. 20 times by 0.7 is 14. So here we've got 14. Now for this one we've got 10 multiplied by 3.2, which is 32. So what do we know so far? We know that 40% of the members have a height in the interval 160 to 170. So we've got 40% of all the members equaling 32. So if we let x equal all the members, then we have 40%, so that's 0.4, times by x, so 40% of the members, and we know that this is equal to 32, which means if I find out how many members we have in total, 32 divided by 0.4 is 80, so we have 80 altogether. We have 80 for all our bars. Now, we know that 40% is between 160 and 170, 30% is between 170 and 180. So, if we work out 30%, so that's 0.3, of all the members, then working this out, 0.3 times by 80 is 24. Which means that there are 24 people in between 170 and 180. So if we've got 24 people between 170 and 180, the frequency density in this case, that will equal 24 divided by the class width of 10, which is equal to 2.4. So what I need to do now is draw a line up from here up to 2.4, and therefore we have the next part of our histogram completed. We know we have 24 people here. And then from 180 to 200, Well, we have 80 members in total. We then subtract 14 from this interval. We subtract 32 from the other interval. We then subtract 24. And if we work this out, 80 subtract 14 subtract 32 subtract 24, we get 10. So there are 10 in between 180 and 200. So between 180 and 200 we have 10. And what we can do in this situation then is work out the corresponding frequency density. The frequency density is equal to the frequency 10 divided by the class width of 20. So we get 0.5. So if I draw a line going across and then a line going down, what you can see here is our completed histogram. We've got 10 people over here. So this is our completed histogram. Question number 14. We have to find the coordinates of the turning point of the graph of y equals x squared plus 6x plus 17. Well, because it says find the coordinates of the turning point, what we would have to do is complete the square. So we begin with y equals x squared plus 6x plus 17, and we can complete the square. We first of all open up our bracket, we write an x in it, half the coefficient of x, so half the 6 is 3. So we have x plus 3, close bracket, all squared. Then we subtract the square of 3 and then add on to this 17. So we have y equals x plus 3 all squared minus 9 plus 17. That's the same as 17 subtract 9, which is 8. And at this point we can straight away spot what the coordinates of the turning point are. We have minus 3, 8 as the coordinates of the turning point. Question number 15. Here are the first 4 terms of a quadratic sequence, minus 1, 3, 13 and 29. The nth term is a(n) squared plus bn plus c. We have to find the values of a, b and c. First of all, here is the sequence. What we can do is find out the difference between each of the terms. Here we've got 4, here we've got 10, here we've got 16. Let's now find out the difference between these terms. Here the difference is 6, here the difference is also 6. So what we do with our second difference is we divide it by 2. So 6 divided by 2, that's 3. So we have a 3n squared. Now, to find out what b and c are, let's first of all write out the n squared terms. We've got 1, 4, 9 and 16. Then the 3n squared terms, we multiply each of these by 3. 1 times 3 is 3. 4 times by 3 is 12, 9 times 3 is 27, 16 times 3 is 48. We then write out the sequence. The next thing we do is we write out the sequence, subtract the 3n squared terms. So, minus 1 take away 3, that's minus 4, 3 take away 12, that's minus 9, 13 take away 27, that's minus 14, 29 take away 48, that's minus 19. So, if we now find the difference between each of these, Here we've got minus 5. Here we've also got minus 5. And here we've got minus 5. And if I do the opposite of minus 5, that's plus 5. Minus 4 plus 5 is 1. Which means our nth term is 3n squared minus 5n plus 1. Which means the value of a is 3. The value of b is minus 5. The value of c is 1. Question number 16. The formula P equals 6,800 times 1.045 to the n is used to predict the population P on an island n years after 2018. For part A, we have to write down the population of the island in 2018. Well, that is when n is equal to 0. So we have P equals 6,800 times 1.045 to the 0. So it turns out the population in 2018 is 6,800 because 1.045 to the 0 is 1. So we've got 6,800 times 1, which is 6,800. Then for part B, we have to write down the percentage growth rate used in the formula. Well, we have 0.45 more than 1, which means we have 0.045 as our decimal multiplier, and if I multiply this by 100, it turns out we get 4.5%. And then for part C, for the first part, we have to work out the population predicted by the formula in the year 2030. Well, from 2018 to 2030, we have 12 years. So the population is equal to 6,800 times 1.045 to the 12. And if I work this out, we get a value of 11,531.99, etc. So it would be sensible for us to write down a value of 11532. Then we have to give a reason why this answer may not be reliable. Well, that's because the rate may not continue. Question number 17. The diagram shows triangle ABC. We've got AC, which is 48mm, and BC, which is 85mm, and the angle BAC is 53 degrees. We have to calculate the length AB. Well, if I call this length of AB x and the units will be millimeters, then what we can do is use the cosine rule. We've got 3 sides and the angle included. So using the cosine rule, we have 85 squared equals 48 squared plus x squared, subtract 2 times by 48 times by x times by the cosine of 53. So what we need to do is find out what x is. So if we were to find out what x is, well, let's rearrange this so we have a quadratic. We've got x squared And then if I work out what this result is, we've got minus 2 times by 48 times by the cosine of 53. So that's minus 57.77 etc. x's. And then if I do 48 squared subtract 85 squared, we get minus 4921. And the result of all this is equal to 0. So now we need to solve this quadratic, and for us to solve this quadratic, we can use the quadratic formula. So, well, here is a reminder of the quadratic formula. We've got x equals minus b plus minus the square root of b squared minus 4ac over 2a. We can see that a is 1, the value of b is minus 57.77 etc. The value of c is equal to minus 4,921. So now let's find out what x is using the quadratic formula. So here we've got our quadratic formula with the values of a, b and c substituted in. Now the way I will do this answer I'm going to store into b. The value of 1 I'm going to store into a, and the value of minus 4921 I'm going to store into c. So now when I type in all of this into my quadratic calculator, I've got minus b, so I've got minus b, we'll do with the plus 1, and I've got plus the square root of b squared minus 4 times a times c divided by 2 times by a. So one value of x is 104.75 etc. The other value, well, we just need to take the negative instead. And it turns out we get minus 46.97 etc. Now it makes sense for us then to take the positive value, and that's because x must be greater than 0. So because x is greater than 0, we can conclude x is equal to 105 to 3 significant figures. So let's put over here 105 given to 3 significant figures. Question number 18. For each graph below, we have to select its possible equation from this list. Well, the first one looks like the graph of tan. And what we'll do is we'll add on some asymptotes for that. So we've got asymptote here, and we've got another asymptote over here. So we've got y equals tan x. Next one, we've got something which is an exponential graph, so the only one that could be, because it passes above the x-axis, crosses the y-axis at 1, it could either be 3 to the x or 1/3 to the x, but because this is a positive graph, we select the y equal 3 to the x. Now we've got the sketch of y equals x cubed. Here we have to sketch the graph of y equals negative x cubed. Well, we'll take this graph of y equals x cubed, which is currently this graph here, but then what happens with the graph of negative x cubed so we have something like this, and then for the next one, x cubed subtract 8. So here is x cubed and we need to subtract 8, so we move it 8 units down. So we've got this graph over here. Now what we have to do is show the intercepts with the axis. So for us to show the intercepts with the axis, when x is 0, we've got y equals 0 cubed subtract 8, which is equal to negative 8. And when y is equal to 0, I've got 0 equals x cubed subtract 8. So x cubed is equal to 8, which means x is the cube root of 8, which is equal to 2. So it crosses here at 0 minus 2, crosses here, rather 0 minus 8, crosses here at 2, 0. Question number 19. ABC is an isosceles triangle. The sides of the triangle ABC are all tangents to a circle of radius 6 centimeters with the center of O. And the angle BAC is 70 degrees and BA equals BC. And we have to show that the length BO is 17.54 centimeters, correct to 2 decimal places. Well, because we've got an isosceles triangle, we can say then this angle is 70 degrees and the angle here is 40 degrees. Angles in a triangle add up to 180. 70 plus 70 plus 40 is 180. Now we have to find the length of BO. So if I draw a line over here, what we need to find is the length BO. Now, before we do anything else, if I find out what this angle here is, that's half of the 40, which is 20. So we've got 20 degrees. Now let's draw a right-angled triangle. We've got B over here, O over here, and this point over here. We've got a right-angled triangle. We've got the 20 degrees over here, and BO is the hypotenuse, so this length here is the hypotenuse. We are given the 6 centimeters here. So we've got the opposite, the hypotenuse. What connects those is sine. So we've got sine of 20 equals opposite over the hypotenuse, which is BO. We need to find out what BO is. So to find out what BO is, we have 6 divided by the sine of 20, and working this out, 6 divided by the sine of 20 is 17.54, etc. So we have 17.54, etc. And to 2 decimal places, indeed we do get 17.54 centimeters. And that's exactly what we wanted to show. Then for part B, it says find the area of the triangle ABC. Well, if I go back to the diagram, what I can do is add on this line here, which is just an extension of BO. And if I call this point M, this will be 6 centimeters because it's still a radius. We're going from the center to the circumference. We've just found this to be 17.54. Now what we can do is construct another right angled triangle. Let's first of all find the length BM. BM, we've got this 17.54 plus the 6, so we get 23.54. And if I construct a right angled triangle, then here we've got the 23.54. AM is what we're finding, and here we've got 70 degrees. Now if I find AM, I can double that to find out what AC is. So again, if we use trigonometry, we've got the opposite and the adjacent. What connects those is tan. So we've got the tan of 70 equals opposite 23.54 divided by the adjacent AM. We need to find out what AM is. So I've got 23.54 divided by tan of 70 degrees So if I work this out, we get a value of 8.56, etc. So therefore AC is double this. So I've got 2 times by 8.56. So if I work this out, we end up with 17.13, etc. So if I construct a isosceles triangle, we've got A, B, and C. We've got the height of the triangle being 23.54. We have the base of the triangle being 17.13, which means the area is equal to 1/2 times by the base of 17.3 times by the height of 23.54. So if I work out the area, then we end up with 201.7 centimeters squared given to 1 decimal place. So we have 201.7 centimeters squared given to 1 decimal place. Question 20, we have to solve algebraically y equals x plus 3 with x minus 3 all squared plus y squared equals 50. Well, if I call this 1 and this 2, we can substitute in 1 into 2. So we've got x minus 3 squared plus y squared, which is x plus 3. Then I square it. The result is 50. So I've got x squared minus 6x plus 9 plus x squared plus 6x plus 9 equals 50. So I've got 2x squared plus 18 equals 50, which means that 2x squared is 32, x squared is 16, so x is plus minus 4. When x is equal to 4, y is equal to 4 plus 3, which is 7. When x equals minus 4, y equals minus 4 plus 3, which is minus 1. So now we can write out our solutions. X is 4, y is 7, x is minus 4, y is equal to minus 1.